Okay, this one is going to be a bit different. I want to rewrite the ping command in this one because I think it's a fun, small network challenge, especially for beginners. If you've never written a little network application in C, I think this is ideal. And it's also a bit different from the usual network application. So yeah, that's quite nice. Anyway, let's get into it. I will also just pause when I code in this video to not bore you just watching me type. I think I'll just say something, then pause, type it out, and then unpause, and so I will explain the code after I typed it. I think it's easier. So anyway, the ping protocol is actually, well, it's not called the ping protocol, first of all. It's called the ICMP protocol, and it's a protocol that goes a bit on top of the IP protocol. So if I did a little packet structure thing. So this is like the network stack as it's usually explained. So it's like the OCI model, 6 layers, I forgot how many layers, whatever. So at the bottom you have Ethernet, actually at the bottom you have the hardware, and then you have Ethernet, then you have IP, and then you have the transport layer, which is TCP or UDP, and then you have the application layer, which is HTTP or FTP or something else. And ICMP is just on top of IP, so it doesn't rely on TCP or UDP. And so this is, for example, like ICMP stands for, I think, Internet Control Message Protocol. I'm not 100% sure, but originally I think it was used to actually kind of just, do all kinds of things on an IP network. So it could be used for time synchronization or telling a thing to now this is the new route you should use, or in our case, what we're gonna do right now, just send something somewhere, and if it responds, check if the connection exists. And so that's called that's what an echo packet is. And so the ICMP packet is very simple. You have the type. In our case, it will just be an echo type. Code, which I forgot. I think that one can be 0. And then the checksum. The checksum is computed exactly the same way as the IP protocol. An identifier and a sequence number, and then some data. So yeah, let me just go back to the main. And first of all, what we have to do is, of course, get like the destination where we want to ping. So I will just quickly write some code that converts a domain name into an IP address. Okay, so that's done. Now we have this domain name, in this case just google.com, and using the getAddrInfo function, I'm able to do a DNS resolve, and at the end I just get an IP address. And so the address is stored in this destination addr_info structure, and I just do a little bit of magic just to be able to print the IP. So you can see that on the side it works. Now that we have this destination address info, we're going to be able to use it when we send and receive messages. So the next step is to actually create the socket on which we're going to send stuff. And so this is a bit special because it's using AF inet, so just like your TCP UDP socket, which you maybe have already done. And then we're going to use AF dgram, which is for connectionless protocol. So usually you use it only for UDP, but actually it can be used also for ICMP, because ICMP is also connectionless. And then we're just gonna specify IP proto ICMP next up. And this will create a ICMP socket, kind of. So the kernel will handle all the IP related stuff for us, and we will be able to just build our ICMP header and send it. So let me just, this is not AF, this is SOC. But yeah, let me just now try to build a ICMP header, and I'll get back to you after it's done. Okay, so that's mainly done. So here is our, we have actually Linux provides a struct already for us for this. So it's called the ICMP header, which is in netinet IP ICMP.h. And I set the type to ICMP echo, the code can be 0. The checksum, we will fill it right after I explain this, but it should be at 0 for now. The ID, I don't know what it's used for. The sequence is generally when you send multiple ICMP packet one after the other, you want to increment this by one every time so that you know that this packet I sent correspond to this packet I received, and you can match them together and so on. So let me now just quickly put the checksum computation in the code, and I'll show you how it's done. So here, now, right after I initialized my packet, I will compute the checksum on it. And so the checksum works by summing every block of 16 bits together, like so. This is the checksum function. So we have a pointer to uint16, and we will loop over all of those block of 16 bits, add them up together, and we put the sum in a 32-bit integers, and then we basically add the two 16-bit parts of the 32-bit integer together, and we knot them together. So yeah, this is the same way it's done for the IP packets. I think this is called actually I forgot what it's called. So yeah, maybe you can tell me in the comments if you want. But yeah, there is a really interesting video of by Ben Ether, I think, on this, so you can go watch that. But yeah, this is how you do the checksum. And now we will send our packet to somewhere, and like so. I should put the result here. This is just going to be packets. It's going to be packets, and as you can see, I'm cheating a bit because I already implemented that like 3 years ago, and I just thought it would be cool to have a YouTube video about it. So I'm copy pasting a lot of stuff and just simplifying a bit what I had written in the past. And it's to be different than -1. So now this should send our packets into somewhere, but of course we don't receive yet, so it's like nothing happened. And let's just, yeah, this is the send to. I don't know if you're familiar, but so when you create a socket, you can use the plain write on it, since it's a file descriptor, so you can just write some data to it. There's also the send, which is basically the write but with some flags, and there is the send to, which is like send, so it has the socket, the data, the size of the data, the flags, and then you can specify as well where you want the address of where you're going to send the stuff. So that's why we use it in this case, because we need to specify, yeah, the destination address, of course. And so just like there is a send to, there is also a receive from, like so, like so, error, like this, and I guess we can just reuse the same packet, because why not? So yeah, that's a bit, maybe that's a bit confusing, but I hope not too much. And so yeah, again, we receive from the destination something. Let's make sure that there is no error. And here we can just print received pong, something like this. Boom. And hopefully that works. Oh, there you go. We received the pong. So we just pinged google.com and we received our packet back. And yeah, I think that's about it for this video. Oh, sorry, maybe I punched you. I guess, well, the microphone is you, so. Yeah, in my original implementation, I have the whole system of making a loop and ping multiple times and stop on Control-C and then print the little sum, like so, and then you have each line, and then when you Control-C, you have the statistics. I implemented all that, but I think that would be not so interesting. I think the most interesting part was seeing that, yeah, this is how you create an ICMP packet. how you do the checksum, how you can send and also include the destination and receive from a destination, and how you can create a socket that is an ICMP socket. That was also quite interesting, I think. So anyway, if you like this style of video, just let me know and I will make some more. I have already some ideas about rewriting the traceroute command, which is also based on the IP protocol originally, and some other cool stuff. So just let me know if that's something you'd like to see, and I'll see you in the next one. See you.